Hi! Today we're going to learn about functions. So today our goal is to determine whether the given is a function or not. First, let's review what a function is. Take note, a function is a relation in which each element of the domain, that is your x, is paired to exactly one element of the range, which is y. There are different ways to represent a function. In this video, we will discuss 5. First, the set of ordered pairs, the table of values, mapping diagrams, graph, and equation. First, let us discuss how to determine if the given is a function or not using the set of ordered pairs. Now take note the set of ordered pairs, or that is represented by x, y. So these are two numbers separated by a comma, enclosed in a parenthesis. Now how do you determine if the given set of ordered pairs is a function or not? Now take note what you have to look out for here are the x values. So the x values are the first element in each of the ordered pairs that we have. Now, for example, we have the set A that is composed of the ordered pairs 1, 2, 2, 4, 3, 6, 4, 8. What we have to look out for here is that there should be no two x elements that are the same. So when we say no two x elements are the same, so there should be different x elements in all of our ordered pairs. Okay, so let's inspect A. We have x elements are 1, 2, 3, 4. So there is no duplication of the first element, which is x. Therefore, set A is a function. Next, set B. Now again, let's look at the set of the x elements. Okay, so since there is no duplication of the x elements for set B, then set B is a function. Next, set C. So we have negative 3, 8, negative 2, 5, negative 2, 3, negative 1, 1, and we have 0, negative 1. Now take note, for this set of ordered pairs, okay, if you notice, negative 2, 5 and negative 2, 3 both have negative 2 as their x element. Now since there are two ordered pairs with the same x element but they have different y elements, then set C is not a function. Next, let's proceed to set D. Now for set D, we have negative 1, negative 5, 0, 0, 1, 5, 2, 10, 3, 15. Again, if we inspect all the x elements, there is no duplication. Therefore, set D is also a function. And the last one, set E, we have negative 1, negative 4, 0, 1, 1, 3, 2, 5, and 0, negative 2. In here, we have two ordered pairs, which are 0, 1 and 0, negative 2, which both have 0 as their x element, and we have two different y elements paired to 0. This time, since 0 is used as the x element in two different ordered pairs which contain a different y element, so this is not a function. Again, we have set A, set B, and set D are functions, while set C and set E are not functions. Next, how about if we have the table of values? Again, we use the same rule as when we have the set of ordered pairs. So for table of values, we also look out for the x elements or the first element in our table. Now, letter A, we have -2, -4, -1, -1, 0, 2, 1, 5, and 2, 8. Now, take note, all the x elements are different. There is no repetition of our x element, therefore, set A or table of values for letter A is a function. Next, for letter B, we have 1, -1, 2, 0, 3, 1, and 2, 4. Now, take note for letter B, we have 2, 0, and 2, 4. Both have 2 as their x element. Since 2 is repeated or is duplicated as the x element, therefore, set B is not a function. Next, set C. We have 2, 1, 4, 3, 6, 5, 8, 7, and 0, -1. Now, all the x elements are different and they also have different, or they are also paired to different y elements. Therefore, since no x element is duplicated, set C is a function. Let's now proceed to the third representation of a function, which are the mapping diagrams. Now, for mapping diagrams, you have here two circles which are connected by arrows. So these arrows show which two elements are connected from the set of the domain, which is x, and the set of our range, which is represented by y. Now, again, just like our principle for set of ordered pairs and for the table of values, each of our x elements should only be paired to one y element. Therefore, each of the numbers here or the elements here in our x should only be paired using the arrow to one element in our y. Now, the pairing goes this way. So, 1 is paired to 2 because the arrow goes from 1 to 2. Next, 2 is paired to 4. 3 is paired or is matched to 8, and 4 is matched to 11. So, no x element here is paired to more than one element in y. Therefore, this mapping diagram for letter A represents a function. Next, for letter B, okay, we have 1 is paired to -4. 1 is also paired to -1. 2 is paired to 3. 3 is paired to 7. 4 is paired to 12. Now, in this case, 1 is paired to two different values of y. We have -4 and it is also paired to -1. Again, as what I said earlier, each of our x values here should only be paired to one element in the y. Since 1 here in our x or in the domain is paired to two numbers, these are -4 and -1, this makes this mapping diagram not a function, since 1 is paired to two different values in y. Next, let's proceed to letter C. 2 is paired to 3. 4 is paired to 7. 4 is also paired. 4 is also paired to 13. 6 is paired to 3, 13 and 16. And 8 is paired to 16. Now, in this case, 4 is paired to 2 different y values. 6 is paired to 3 different y values. Now, for this case, since 4 and 6 are paired to 2 or more different y values, this also makes it not a function. Okay, next, for letter D, we have 1 is paired to 5, 2 is paired to 10, 3 is paired to 10, 4 is paired to 10, and 5 is paired to 5. Now, let's analyze. Even though there are many y or there are many x values which are paired to 5 and to 10, each of our x values is only paired to one number. Now, 1 is only paired to a number, that is 5. 2 is paired to only one number, that is 10. 3 is also paired to only one number, which is 10. 4 is paired to 10. And 5 is only paired to 5. Now, take note, even though that there are many repetitions for y, there are no repetitions of pairing for x. So, this makes it still a function. Now, this is what you have to take note. Even though there are repetitions in the y values, but if there are no repetitions for the x values, that is still considered as a function. You call that a many to one relation. Okay, so for mapping diagram, only A and D are functions. Let's proceed to the fourth one, which are the graphs. Now, for graphs, we have what we call the vertical line test. For functions or for graphs of functions, we can identify if they are functions or if they represent functions if we do the vertical line test. Now, what is the vertical line test? The vertical line test tells us that if you draw a vertical line anywhere along the graph, the vertical line and the graph would only intersect once anywhere. If the vertical line and the graph intersect twice or more, then the graph does not represent a function. Let's try letter A. Now, let's draw a vertical line here. Now, it intersected with the graph only once. So, that's still good. Next, if we draw the vertical line at a different place or a different portion of the graph, let's see. So, it still intersects with the graph only once. And if we draw the vertical line somewhere else, let's say here, it still intersects with the graph only once. Now, since the graph and the vertical line intersects only once at any part of the graph, then letter A is a function. Next, for letter B, we draw vertical lines here. It intersects with the graph once. If we draw it here, it also intersects the vertical line or the graph once. If we draw here at another part, it also intersects with the graph only once. Now, seeing that it will intersect with the graph once anywhere across the graph, then letter B also represents a function. Now for letter C, if we draw the vertical line here, it will intersect the graph once. But if we draw the vertical line here, it will intersect with the graph twice. Now, this makes this graph not a function. Okay, again, for the vertical line test, no matter where you draw the vertical line, it should intersect with the graph only once. If it intersects with the graph twice or more, then the graph does not represent a function. And the last one, okay, are the equation form of the function. Now, for equation form of the function, you can do many ways, or there are many ways to do this. You could express the equation as a set of ordered pairs, as a set of table of values, as a graph, or as a mapping diagram, and you can use the rules for each of this. But there is another way, or there is a hint on how you can identify whether the graph or whether the equation represents a function or not. Now, what you have to do is you have to look at the exponent of y. Now, if y contains the exponent which is odd, when we say odd, we have 1, 3, 5, 7, 9, and so on, then it will give you a function. Meanwhile, if y has an exponent which is even, that means 2, 4, 6, 8, 10, and so on, then usually it would give you something, or it will give you a graph which is not a function. Now, for example, we have letter A. Exponent here of y is 1. Okay, again, as a review, if you don't see any number as the exponent, it is understood that the exponent is 1. So since exponent here is 1, this is a function. Exponent here is 1, this is a function. For letter C, exponent is 2, which is even. Okay, this is not a function. Now, why do you think so? Now, if y has an exponent which is even, the graph would more or less look like this one. So it would look like a letter C, or it would open the other way around. Okay, and if you use the vertical line test, at some point, your vertical line will intersect with the graph twice. Okay, then, this one is also not a function. Okay, exponent here is 2. And this one, exponent here is 1, so this is a function. Okay, again, as a review, there are 5 ways on how we can represent functions. In this video, we have set of ordered pairs, table of values, mapping diagram, graph, and the equation. For set of ordered pairs and table of values, you have to see to it that there is no repetition in the x variables. For that is also true when we have mapping diagrams. For our graph, what you will do is you have to do the vertical line test. So the vertical line test, you have to draw the vertical line at any point in the graph, and if it touches the graph twice or more, then that's not a function. If it touches or intersects with the graph only once at all portions of the graph, then the graph represents a function. And of course, we have the equation. Okay, I hope you understood all of it. Bye!